given today first problem is use dual simplex method to solve the following LPP. So first objective function is minimize z. So minimize z equal to 6x1 plus 7x2 plus 3x3 plus 5x4. And constants are given what? 5x1 plus 6x2 minus 3x3 plus 4x4 greater than or equal to 12. And second constant is x2 plus 5x3 minus 6x4 greater than or equal to 10. And third constant is 2x1 plus 5x2 plus x3 plus x4 greater than or equal to 8. So first you see your objective function is what? Objective function is minimization. Objective function is minimization, and here all constant part is what? This is greater than or equal to. Okay. So what is the standard form of the dual simplex method? For solving dual simplex method, first we convert it into the maximization, right? And all constant sign should be less than or equal to, right? So given problem is minimization, so first we convert it into the maximization. So how to convert it into the maximization? By minus sign. Okay. So first we write maximize z equal to, then you put minus sign, then minus 6x1 minus 7x2 minus 3x3 minus 5x4. And next we convert the inequality symbol here, greater than to less than or equal to, then we multiply both sides by minus 1. So when we multiply this minus 1, so you multiply both sides by minus 1 for the first constraint, similarly in the second constraint, then third constraint. Okay. Then we get the standard, this is the standard binomial form, right? So next we use which variable for making equality for the first constraint, second constraint and third constraint? For making equality, Arbas? Yes. So for the first constraint, we use what? Slack variable. Similarly, in the second constraint, we use again the slack variable. Third constraint, we use also the slack variable. So S1, S2, S3 for these three constraints, right? So next here, how many equation and how many variable? So here you see 3 equation and 7 variable, right? So for solving this, we take 4 variable is equal to 0, means 7 minus 3 equal to 4. So we consider 4 variable is equal to 0, right? So which 4 variable is equal to 0? X1, X2, X3, X4. We will not consider S1, S2, S3. Why? Because this gives us the identity matrix. Okay, so this S1, S2, S3 our basis variable, right? So next we take X1, X2, X3, X4 equal to 0. Okay, and then we get S1 equal to minus 12, S2 equal to minus 10, and S3 equal to minus 8, right? So on second page, you see, I am audible, no?
Yes, sir.
Yes, sir.
Okay. So for the next second page, you see the first table, same as earlier, right? So first you write capital B, B is the basic variable, CB is the coefficient of the basic variable, then XB is the current basic feasible solution, Then x1 is the coefficient of x3, then x4 is all the coefficient of x4, then s1, s2, s3, right? And cj equal to, cj means coefficient of the objective function. So here you see, same as when we introduce select variable s1, s2, s3, then similarly we write in objective function. Here I have not shown, but you know this plus 0 into s1 plus 0 into s2 plus 0 into s3 in the objective function, right? So next what we do, you put all the values, right? So x1 coefficient, x2 coefficient, x3, x4, s1, s2, s3. Similarly, you s1, then cb, all the values 0, 0, 0. Then xb column you put minus 12, minus 10, minus 8, right? Next, Z, Zp equal to Cb into Xb, we know the formula. So this is 0 and delta J means Cj minus Zj. Okay, so delta J means what? Cj minus Cb into Yj, same as earlier format. So here this is Zj I have written. Next, you see, after calculating delta J, first column gives us the minus 6, second column is minus 7, third column is minus 3, fourth is minus 5, then 0, 0, 0. Then you see, in dual simplex algorithm, no need to find out the, next you check whether this gives us the optimal solution or not. When gives us the optimal solution in the dual simplex algorithm? When all delta J less than or equal to 0 and all Bi is non-zero. Bi means XB column. All XB column is non-negative. Okay, non-negative. So here from the first table, can we say that this gives us a optimal solution?
No, sir.
No. So what we do? So next, this does not give us an optimal solution. Next, in dual simplex algorithm, no need to find out the, means what? No need to find out the minimum ratio. Without finding the minimum ratio, we can mark which row is the key row. Okay. So here, how to choose in dual simplex method key row? Key row, how to choose? Anybody? Ishita? Shubhi, Parvaz, everyone? How to choose in key row in dual simplex method?
So was it
Ripon, Dipanshu?
the smallest XB row? I mean, like for the S1 row, the XB is minus 12, which is the smallest. Was it that way?
Means, yes, you see, in XB column here, elements are what? Minus 12, minus 10, minus 8, right? Minus 12, minus 10, minus 8. Means we consider all the negative value. Okay. If suppose minus 12, minus 10 and then plus 8, then we will not consider 8. Just minus 12 and minus 10 compare with this. So here three elements, these are negative. So we compare with these three elements. Minus 12, minus 10, minus 8. So from these three, which is the minimum value? Minimum is most negative. Okay, we take most negative. So here you see minus 12 is the most negative value, most negative. So minus 12 present in which row? First row. So our S1 row will be the key row. Clear? You see here we did not calculate minimum ratio. So S1 is our minimum ratio row. Just you remember. Means what? S1 is minimum ratio row, right? Next, we find out the incoming vector. So how to find out the incoming vector means key column. How to find out key column, incoming vector or key column. Key column will be calculated in this way: ratio of delta J and negative value of key row element. Okay, ratio of delta J to key row element, corresponding key row element. And key row element, which key row element we consider? Those are negative. Means what? Here you see, first delta J value is what? First delta J value is -6. So -6 by corresponding element of key row is what? -5. So minus minus cancel out. So 6 by 5. So 6 by 5 is 1 point something, right? Next one is -7 by -6. Third one is -3 by, so third one we will not consider because our in third one 3 is positive. 3 is positive value in the key row. So positive value we will not consider. So third one we will not consider. Next you move to the fourth. Fourth one is key row element is -4. Okay, we consider the ratio means -5 by -4. Then next one is positive value will not consider. Okay. Next one is 0, 0 will not consider. Only the negative value present in the key row, then we find the ratio of delta J and key row. So -6 by -5, then -7 by -6, -5 by -4. Okay. So here you see -7 by -7 by, yes, -7 by -6. So this gives us the minimum value. So this gives the minimum value. So our x2 column will be the incoming vector. So if x2 column is the incoming vector, then our pivot element will be -6. Intersecting element is pivot element. So first row and x2 column intersect element is -6. So our in the next table S1 will be out and S1 is replaced by X2. So you go to the second table, you see all these things you fill up: B, CB, XB, X1, X2, X3, X4, S1, S2, S3, CJ value you fill up. Then first row in B, S1 is replaced by X2. Okay, when we write x2, then coefficient of x2 in the objective function is -7. So in CB, this is -7. Again, second row, B value is S3. Basic variable is S3. Its coefficient is 0, remains same. And next one is S4. Coefficient is 0 in the objective function. So this is 0. In
So, like,
CB, this is 0.
will it be S2 and S3? I mean, S3 and S4 are not there, no?
Huh?
So, like, so the rows
Oh,
X2,
yes, yes.
S2 and S3 should be there, no?
Here S1, S2, S3. Okay. So here not S4, this is S3, not S4. Everyone correct this one. This is not S4, so this is S3, S3, and this is S2, S2, and this is S3. Okay, okay, thank you. So in the second table, this is X2, then S2, then S3, not S3, S4. So next one will be you divide the first row by pivot element. So in the first row, you divide the pivot element means what? You dividing this by 6. So when we divide by 6, then we get minus, this value is what? Divide by minus 6. So minus 12 by minus 6 is 2. Then minus 5 by minus 6 is 5 by 6. Then 1. Next one is minus half. Next one is 2 by 3. Next one is minus 1 by 0. Next one is 0. Next one is 0. In the second row, you calculate same as earlier, right? So second row, how to calculate? Old element, new element equal to old element minus intersection of key row, key column divided by pivot element. So how to calculate? Minus 10, then minus symbol. Then minus 1 into minus 12 divided by minus 6. So after calculating, you will get 5 by 6. Then and 5 by 6. Okay. So, and first one is minus 10, how to replace? Minus 10 is how to replace. So, minus 10 will be minus 10 minus 1, minus 10, then minus 1 into minus 12 divided by minus 6. Next, 0, how to replace by 0 in the third table. So, 0 minus minus 1 into minus 5 divided by minus 6. Ultimately, we get 5 by 6. And next one is automatically S1 in the second table. See, in the second table, S1 column is 100. So, similarly, you copy and paste in X2 column. So, X2 column will be like this, 100. So, you see here X2 column will be 100. So, without calculating, we solve. Next one is minus 5 in the second row, second table. Minus 5 is replaced by what in the third table? So minus 5 minus of minus 1 into 3 divided by minus 6. So similarly, in this way you plot, you will get the value. Then S3 row is also you calculate, you will get this value. So you see, this is clear or not? Up to third table. Everyone clear? All of you find out now how to find out the new element in the new table.
Yes, sir.
Binoy?
Yes, sir.
Okay. So all of you calculate in your copy, you will calculate and you will do practice. Okay. Otherwise, in your exam, you will find difficulty. Because this problem in operation research problem, these are maximum is what? Theory portion and calculation portion. If you know the how to solve the problem procedure, know the procedure how to calculate. If you know one problem, then you can solve remaining all these problem, because all these problem based on this one. You see, in simplex method, you calculate new element equal to old element minus intersection of key row key element divided by pivot element. So with the help of this, in all the table we need this formula, calculating the new element. So you will do practice, more practice you need. Okay, so you will do this. Ripon, clear? From so this is second table we complete. Second table we complete. So from second table, here you see, from second table, can we say that this gives us an optimal solution? So from second table, all delta J less than or equal to 0, okay, no problem. But all XB is positive? No. All XB is not positive. 2 and 2 positive. First row element and third row element is positive, but here minus 8. So for minus 8, this does not give us an optimal solution. So next what we do, we remove this one. So you see, our key row will be the second row. In the second table, key row is the second row, because only one minus element present. Negative value is present. So minus 8 means second row is our key row. So next you find out the key column means incoming vector. How to find out? Ratio of delta J and key row element. Which key row element? Those are negative. So you see, first one is in x1 column, second row x1 column, 5 by 6. We will not ratio of this. Next one is 0, will not consider. Next in x3 column, this is negative value. So minus 11 by 2. So we take the ratio of delta J and this element. So minus 13 by 2 divided by minus 11 by 2. Okay, ratio we find out. Next one is 20 by 3 is positive. We will not take this ratio, delta J and this ratio. Next is minus 1 by 6. So this is, yes, we take minus 7 by 6 divided by minus 1 by 6. Next one is 1, next 0. So we get this one. So here only we check the ratio of minus 13 by 2 divided by minus 11 by 2, and next one is minus 7 by 6 divided by minus 1 by 6. So ultimately here you see this x3 column is our incoming. This gives us the minimum value, this ratio. So x3 column is our incoming vector or key column. So when this is our key column, so S2 will be out and this is replaced by X3. Okay. So in the third table, you see X2, okay. Then S2 is replaced by X3 and this is, I have written S4. All of you will correct. This is S3. Okay, S3. Next CB, you write all the coefficients and you calculate. Second row is divided by minus 11 by 2 because minus 11 by 2 is our pivot element. So you divided by each element of the second row. So this. Next one, what we do, similar process, new element equal to old element minus intersection of key row, key column. With the help of this, we get the first row, and similarly, we get this by third row. Okay. So after calculating, we get ZP equal to ZP means final. CB into XB equal to value is this we get minus 258 by 11, and delta J value we already got, right? So here XB is what? 30 by 11, 16 by 11, 78 by 11. All are positive. And delta J less than or equal to 0. Then this gives us an optimal solution. So optimal solution is what? X1 equal to, in the third table, X1 is absent. So X1 is 0. X2 is 30 by 11. X3 is 16 by 11. And X4 is absent. So this is 0. Okay. X4 is absent. So this is 0. So our original problem is minimization, but we convert it into the maximization. So mean Z equal to minus max Z. So max ZP is 258 by minus 258 by 11. So minus minus plus 258 by 11. So you see this is clear or not?
Yes, sir, it is.
Clear. Okay. So in this way, we solve this by dual simplex algorithm. So you see, in your exam, one question came from this portion, dual simplex algorithm. Okay, here maybe 10, 12 marks, right? Dual simplex algorithm. Next, one problem from graphical method and one problem from simplex method. Here in simplex method, either you use the sometimes flag variable or surplus variable mixed up, sometimes only flag variable, sometimes only means what? Surplus variable. Okay, so when surplus variable is used, then we use here artificial variable. Then here we write in objective function capital M. So sometime in your question, ask question like this, solve the linear programming problem by big M method. Then you will not confuse. BKM method, how to solve BKM method. Yes, this one. When we use the artificial variable used in the problem, then this is called the BKM method. Okay, or solve the following linear programming problem by penalty method. Okay, so m is used, so large m and negative minus of m we use, so this gives us a penalty. So this is also another name is called penalty method, BKM method or penalty method, or sometime not mentioned, solve the linear programming problem. Okay, so sometime ask for confuse the candidate, ask BKM method. Okay, so okay, so you will do practice. Okay, and all of you will write immediately. Today I have given this problem, then you will write in your copy. Okay, separately you make one copy for operation research. You make one copy, and all this whatever I have sent in PDF format I have sent. You immediately after the class you will copy this one. Okay, so clear everyone?
Yes,
Anybody
sir.
who have any doubt?
No, sir.
Okay. So response your